The analysis of covariance, Ancova, Ancova, is an extension of the one-way ANOVA from a previous video. This advanced method adjusts the dependent variable scores to reflect the case when participants are equivalent on some third nuisance variable. The goal is to exclude the effect of this second factor. In an experiment measuring comprehension, for example, the experimenter may compare two groups on how well similar messages were organized. It could be low, medium, high organization in a one-way ANOVA. But let's assume the researcher decides to make listening skills a covariate. To simplify the experiment, let's just look at two groups. One control group without any organization cues like previews or summaries, and a treatment group with those cues present. So the dependent variable is comprehension, the experimentally manipulated factor is organizing, and the nuisance covariate, listening skills. In SPSS, go to the Analyze menu and choose General Linear Model, then Univariate. Your dependent variable is comprehension, your fixed factor is organization, and listening skills is your covariate. Click on Options and move all of those variables in the factor box over to the Display Means box. In the bottom part of the options box, choose descriptive statistics, estimates of effect size, and homogeneity, which is like Levine's test when we did the t-test. There are additional options for testing your assumptions of linearity and homogeneity of regression that you can read about in a textbook. But let's focus on the essential output of the Ancova test. Click on Continue and then OK. The first column in the Between Subjects Effects test shows the sources of variation. The intercept is unexplained variation, which in this case is not significant, 0.973. The covariate listening was significant, p equals 0.19. And the intended, that is, manipulated variable, organization, is significant, p equals 0.016. The final estimates after excluding listening skills are the marginal means for comprehension. For the control group, the mean was 6.499, and the experimental group mean was 7.701. With the Ancova, you can usually parcel out the variation from the nuisance variable from the experimental variable. That said, however, the example just shown was less resilient to further testing of assumptions in the textbook example. So you may need to use factorial ANOVA instead of Ancova. Factorial ANOVA is the subject of the next video. See you then.